Okay, welcome everybody. I assume everyone in the back can hear me all right. Raise your hand if you can hear me in the back rows, please. Fantastic. So welcome to this talk on Git and GitHub secrets. My name is Patrick McKenna. I realize the handle's actually tucked away in the bottom right-hand corner where most of you probably can't see it. I apologize for that. It's just my name, concatenated, Patrick McKenna. So that's me on the GitHubs. I'm a trainer at GitHub, so I spend a lot of time teaching online and going and visiting with people in person, teaching them how to use Git and GitHub. So today's talk is billed as Git and GitHub secrets. Secrets is, of course, a pretty subjective term, right? It means a lot of different things to different people. And especially when we talk about Git, there's all manner of esoteric stuff that we could get into, and most people would probably define as close to secret. But I don't want this talk to be about that because that's only interesting to a tiny subset of the audience. So the goal here is to cover Git and GitHub features that may be very well documented, but which we have found in going out and doing training and speaking with customers and users are pretty underappreciated and underused. So that's one category of things that we want to cover today. And then the other mixed in is some ways that we at GitHub have actually come to use the product as we build the product. So a secret in the sense that you probably don't know about this unless you happen to have worked at GitHub, but many of you may already be using some of these tricks already. But those are, broadly speaking, the two categories that we want to cover. So the first thing, a note just for you people out there, I will be posting these slides, of course. I just omitted the domain for clarity's sake, so you're not going to see that. So you should prefix everything with github.com, or if you're an enterprise customer, whatever your host name is for your enterprise install. So the first thing I want to say is, okay, assume that you're coming into a new project. Maybe you're a team lead. You've been assigned to take it over, but you want to figure out who's been contributing what. You can, of course, you can filter for commits by commit author on the command line, but it's also something you can do in the web UI. So replace user and repo, of course, with the appropriate individual user or organization account, then the repo name, and then if you add this question mark author equals, followed by the GitHub handle, you can go ahead and get a list just of commits by users. So I've taken as the example, actually, Techno Weenie, whom some of you may have seen. He's given a talk about Git LFS, which most of you probably know, hit 1.0 just yesterday. But the idea here is, yeah, it's so hopefully that has a lot of you excited. We're pretty stoked about getting LFS out to a 1.0 state. But this is incredibly useful. So yeah, it's something you have to type into the URL, but as someone I work with once pointed out, it's hard to beat the speed of a URL bar. So yeah, there's not a button for this immediately, but as soon as you get pretty comfortable, especially for those of you that like to live on the keyboard and don't like to touch the trackpad, it's pretty quick. So another useful thing that a lot of people don't know about is what we like to call our compare view. All right, so if you're jumping into a new project or you're looking at a repo that you've been working on in some time, you want to be able to compare the state of different branches, let's say. So if you just hit this URL, you will get a interface that looks something like this. Gives you true drop-down menus and lets you pick, all right, what two states, what two revisions of your project do you want to compare? So that's useful if you want to be able to browse through the actual drop-down menus. You're not sure what you're looking for. But you can also just go ahead and, again, just type the URL in directly. So user repo compare. Commitish here is Git lingo. Really what it means is a commit SHA, a branch, a tag, or actually a point in time. So for those of you that are used to things like head at one.day.ago, that's also acceptable. But if you want to just keep it simpler, commitish is just, think of it as a branch name or commit SHA, and with triple dots in the middle right there. So there's another thing, and that will go ahead and give you an output a lot like this. So when we type into the URL bar, master ... fetch deleted files, what you're going to see on this output right here is a list of commits that are not on master, but are on fetch deleted files. So really handy if you don't want to jump back and forth between the command line and the web interface and want to be able to get a sense of where your project is according to different branches. So another thing that's really handy is to be able to actually suppress whitespace errors. This happens a lot. People will forget to set up their Git environments properly. It's common especially when people are working cross-platform. If you have some people on Windows machines and others on Linux or OS X, those two systems treat line endings differently, and so you reach a state fairly frequently where people forget to set Git up properly and you get whitespace errors. But if you just plug $w=1 onto the end of a given diff URL, you can go ahead and suppress that. So rather than seeing something like this, you get to something like that, and which is kind of nice. Another really useful thing to be able to do with just a little URL hacking, as we like to call it, is to be able to highlight specific lines. So assume, again, you're coming into a project, you found some file that includes, say, a function definition that you really like, or an implementation of an algorithm that you find especially clever or maybe even problematic, and you want to point this out to your teammates. Well, you don't want to just send them the URL for the file itself, because then they have to go hunt down what the actual lines are. So if you can just add #L1-L2, where you should sub in for L1 and L2, whatever the line numbers are, you can go ahead and highlight the lines directly. So instead of something like this, you go to that right there. And if you don't know ahead of time what lines you actually want to have highlighted, you can actually do this via the web UI. So from that previous state right here, I could go and I could use my mouse and I could click over any one of those integers on the left-hand side, the line numbers, and then I could shift-click down and highlight a sequence of lines, and that will automatically adjust the URL. Go ahead and copy-paste that and send that on its merry way. So there's one thing you want to note here. This works for plain text files, so that Travis config file right there, the YAML file. It does not work for text that gets rendered, so Markdown, for example. Markdown we render for you on GitHub. That's one of the things that we think is quite nice about it, but you don't get the highlighting for stuff like that. Another just kind of lighthearted one is the shortcut to get to your avatar, actually. So if you just go to github.com/yourusername.png, you will actually get the avatar, so you don't have to go right-click and figure out what the actual official URL is. We'll just go ahead and forward you onto that. So it's really handy if you need to be able to include an image easily, like say you want to give a shout out to somebody in the Readme. All right, it's really nice. So what if I want to give some credit to probably Corey at GitHub? That's great. All I need to do is add his handle.png, and bam, we can get it to show up in the Readme. So actually, I could not identify probably Corey for a long time because this is all I saw. So I didn't know who he was in real life. Another really handy thing that a lot of people, I think, don't know about is one of these other special files on GitHub. Most everybody knows about the Readme. If you don't, please make sure to include a Readme, the top level of all your repositories. It's a great way to let people know what the project's all about. We will render the Readme on the homepage. Pro tip, you can actually include Readmes in subdirectories, and those will also render as well. So you're not limited to just one per repository. But we also have this other special file. I say special because Git has no notion of a README or a contributing.md file. In this case, if you write this file, what's going to happen is we will display a little banner whenever anyone tries to open a pull request. So if this is your default view right here for opening a new pull request, if I have added a contributing.md file, you'll see this banner actually pop up, the yellow banner right there. So it's not a hard enforcement. You're not forcing anybody to go through and say, all right, look, I'm going to read the guidelines, I'm going to check things off, and so on and so forth. But it's a nice, simple reminder right there, something that's a little more lightweight to help you encourage a culture of obeying whatever practices your team has decided are best. Some other handy things that people will overlook oftentimes, even though Markdown syntax is pretty straightforward to go look up, you can actually do internal links. So not only can you do outbound links, but if you want to link to different sections within a single Markdown document, that's the syntax for you. Not all that sexy, I understand, but very useful and underappreciated. Likewise, you can do links with relative paths, which is especially handy when you have a lot of text documents, let's say documentation in your docs folder. Instead of having to actually type in all those different URLs, you can just use this instead. All right, so oftentimes people are coming to projects and they see new threads, new issues posted, and they have a lot of different conventions. You want them to include a lot of the same information. So how do you templatize issues? How do you get people to actually fill in some relatively consistent information each time they open a new one? Well, one way is to construct URLs like this. So obviously you don't want to include the line breaks. That's just for legibility on this slide right here. And it's relatively straightforward. User repo issues new, title, whatever you want there, ampersand, so on and so forth. And this will let you construct a link for people they can go ahead and click on, so that if you had this particular link in your, say, Readme or contributing, you would get something like this. A wonderfully descriptive and informative your title here, your text here, your label here. Just a side note, if you happen to include in this URL a label that your repository doesn't have, it's just like a no-op, nothing happens. We don't make up a new label for you. But incredibly useful. We use it internally at GitHub a lot because there are more and more people at GitHub, and we certainly don't know how all the different teams like to work, especially if we're not working with each other on a day-to-day basis. So to make things simple, we'll include a README, of course, and then in that README say, hey, if you want to ping this team, go ahead and click on this link and just fill in the blanks right there. So it's a way to enforce some more consistency as more and more people collaborate across projects. Keyboard shortcuts. This is something of a revelation, I think, for most people the first time they see it. It certainly was for me and most people that I speak to. If you don't like to work with the trackpad, Shift ? Is your friend. It will bring up a context-sensitive menu of keyboard shortcuts. Context-sensitive meaning what's actually going to show up here will depend on what page you're looking at. So if you're at the top-level page for a repository, this is what you'll get. You'll get a different set of options if you're in the issues page, likewise for pull requests. There is no keyboard shortcut to show all keyboard shortcuts, unfortunately. So you do have to click Show All, and then you get the full list, at least as it shows up on a repository homepage. This gets to be incredibly useful, especially for people like myself who do not like to keep moving our hands off the keyboard. There's a lot of stuff there. Don't expect yourself to memorize it all. There's no need to. It's like trying to memorize all the flags for a given Git command. It's just a waste of time. But you'll find yourself coming back to, say, 6 to 10 of them pretty frequently because they are really handy. Fuzzy File Finder is one of those 6 to 10 that most people will be using. We got a chuckle back here from Brent, who loves the Fuzzy File Finder. So you're looking at the code for your repository, and you don't remember what file it is you're looking for exactly. So just go ahead and hit T, and you pull up this dialog right here. That's exactly what it sounds like. So the fuzzy part of things, meaning you don't need to spell a name exactly as it is. So if it's node version, for example, you could just start typing version, and it will start filtering down, and node version will remain among your options. You'll also want to take note of the keyboard navigation right there within the Fuzzy File Finder. So it's really nice. It's a text editor-like feature that shows up in the web UI. So imagine you're looking for a particular file, but you can't exactly remember the file name, and Fuzzy File Finder hasn't worked for you. Another option that a lot of us use internally is, all right, well, let me try to find the associated issue or pull request. Maybe that'll lead me there. I remember what the general discussion was. I remember maybe who was talking about things in this pull request. So let me go find the associated issue or pull request. So you can go ahead and use some of the more advanced search filters. If you click on filters, say if you're in the issues page, you'll notice that bottommost option, which will actually open in a new tab a list of all of the filters you could possibly use in different scenarios. One of them that we think is particularly helpful is something like this. So this will actually show you all issues or pull requests, depending on where you're searching, that have the ship it squirrel somewhere in one of the comments. So for example, if I did that search in the Atom repo, you'll see there's one open pull request that says ship it, so somebody probably should ship it, and 31 that have been closed. Incidentally, that works for any emoji. So if you have a different convention, if you don't like the ship it squirrel, you think it's played out, and you want to do something else, search for whatever. Another, an example search here that you might want to do when you're looking through pull requests, looking for that particular file. All right, I want to find everything that is going to be merged into master, but hasn't been merged yet, and has been updated since yesterday. There's the page that you actually get linked to from that drop-down menu for View Advanced Search will tell you about all the different formats you can use for that date. But yeah, the ISO standards are one easy one. So yeah, this would be every pull request that's not merged, that's going to be going into master and updated since yesterday. You can also do date ranges and a number of other things. So this is an example of what that looks like as of yesterday in the Atom repository. Notice the bottom of the screen actually also shows our little pro tip that'll pop up. If you want to just find a particular thread that mentions a user, you can use that mentions : GitHub username syntax. All right, so imagine that you can't find something in the fuzzy file finder, you're having trouble finding the associated issue or pull request, and you need to actually just get down to the command line. A lot of people don't know about this particular option for the Git Log command. So what this is going to let you do is actually output all commits that touch a given function in a given file. So obviously Git's going to do some guesswork here and so forth, but it's usually pretty good. So it's pretty straightforward. The output you'll get is something like this right here. So we're searching for all commits that are going to touch the Atom initialize ICU and start node function in the Atom library main header file right there. And you can see the beginnings of the output for that. What if you don't know the exact function name? You just want to search for a more general string? You can use this syntax right here. log-cap-s followed by a string. There's a similar switch if you want to actually use a regex. But if you know the string itself and you don't need to be using regexes, this is the format for you. Fairly straightforward. So show me everything in the Electron repo that includes the word selenium is this example right here. Finally, you can also get, just a little bit of an aside, you can get the history of given lines of a file on the command line. So again, fairly straightforward syntax here. So L1 and L2 are the beginning and the ending lines that you care about, : the file name. And this would be an example again of this. So give me the history of lines 11 through 20 in the Atom main delegate header file. So really handy to be able to find things quickly. To really use Git effectively, you need to be able to search through history with some degree of ease. I mean, it's great to know that everything is saved in history. That's wonderful. Maybe that provides you some peace of mind. But if you can't find this stuff, it's going to not be all that useful for you. So commands like this are really great to play around with, and you probably want to include in your repertoire, because that's what's going to actually let you find all those different versions of things through history and make maximum use of Git. All right, so imagine you've found a particular file now, be the fuzzy file finder or using the command line options we just found or through some other method, and you want to open a new pull request. So say you need to do some refactoring of foo, right? You know it needs to be refactored, but you don't have the expertise, or you don't have the time, but you want to open this pull request. You want to get the pull request open early because you want to start the conversation early and make sure it's all captured in a single place. So one thing, in order to open a pull request, you of course need a new branch. And you also need a unique commit. So if you want to merge into master, you need some non-master branch. And that non-master branch has to have at least one commit that does not live on master. So what do you do in the case of wanting to open the pull request, but you have no idea what changes you actually want to make? Well, there's this little hack of sorts. You can make an empty commit on the command line. And then go ahead, that will be your unique commit, push it up to GitHub, and then go ahead and open the pull request. So this is what that would look like right here. I now have a pull request open. I have a place to start the conversation about what should go on without having made a single change yet. And this actually gets back to the point I was mentioning just a few moments ago, which is opening pull requests early. Especially for newer users, you may not feel very comfortable opening a pull request on work that you don't feel is complete. Understandable, natural. Nobody wants to do something other than put their best foot forward, right? But we recommend against that very strongly, and we highly encourage you to open pull requests early and to start that conversation early, and for a whole manner of reasons. Number one is maybe somebody wants to help you. It's much better to get their help at the beginning than it is when you're almost done. Number two is maybe the approach you're taking is going to be something that requires a lot of careful thought, and you want some idea of how to architect the solution. You, again, want that conversation to happen in the beginning before you've chosen a particular path. Then there's a third reason, which would be maybe the path you're actually walking down is going to conflict in some way with other work that is happening currently or will be happening in the future. Your boss comes to say, oh, by the way, no, we can't use that library because X. You want to know that before you use that library and then have to change your entire set of work. So open pull requests early, and if you really don't know what you're going to do in that pull request, just make an empty commit. One of the other things that we use a lot is really just commit a file that has nothing in it. If you know you need to make something new, but you're not sure what should go in the file yet, you can always commit an empty file and open a pull request that way. All right, so once you've got that, when you're actually opening this pull request, there are a number of keywords that you can use. So fix, close, resolve, and the different tenses of each of those, so 9 combinations in total, like fix, fixes, fixed, so forth. When you put those in front of an issue or pull request number, what will happen is that issue or pull request will automatically get closed as soon as you merge the pull request. So for example, right here, I say fixes number 12. So as soon as this pull request gets merged, issue number 12 will automatically get closed. Really handy if you have a workflow where you say introduce bug reports in GitHub issues, and somebody needs to open a pull request once they've seen the bug report in an issue, and you want to just be able to automate the closing of that particular ticket, right? Makes perfect sense. This also brings up cross-linking. If you haven't seen it before, you can link between different issues and pull requests by just including the appropriate integer right there. So just # and that integer, we will automatically turn into a link and take you to the associated issue or pull request in the same repository. So fix, close, and resolve, they also work in commit messages. So Git, of course, has no notion of fix, close, and resolve because this has to do with pull requests and issues. But if you include any of those keywords, followed again, same exact syntax, followed by # and the issue or pull request number, the same action will happen. When that pull request is merged, you go ahead and close the issue. Canonical URLs. Why? Okay, that's not a very exciting slide. I realize that. This is probably the most exciting thing I learned, though, relatively recently, and I'm sorry I didn't know it earlier. So if you need to, within, say, a pull request, link to a specific version of a file, usually what people are going to do is they're going to do something like this. This is the default URL you're going to get. In a given repo, blob, the branch name, and followed by the file name and the path to that file. This is what we show you by default. So if the branch is master, for example, and path spec is just readme, this link will always take you to whatever version of the readme exists on the master branch at that time. So that presumably is going to change as your project advances and as the master version of your readme changes. Sometimes you want to link to a particular revision, though. You don't want it to actually automatically update. So the case of a pull request would be a common one. You want to compare what's happening in your pull request with a specific version of a file on another branch, and you don't want that to get automatically updated. If you are looking at that file on GitHub, if you are at a URL like this one and you hit the Y key, you will get a URL that looks like this. Not terribly different. But instead of the branch name, we end up giving you the commit SHA. And what this is going to do is link to that specific version of the file at that specific commit. So that link will always point to that same version and will not get automatically updated because we're not using the ref, the branch name itself. The branch, of course, will move forward in time. So here's hello world right here, and then once I press the Y key, you'll notice it shows up slightly differently. So the drop down, instead of being branch master, is going to say tree, followed by that abbreviated SHA right there. For those of you that know Git internals, incidentally, 08dd in this case is not actually a tree, it's actually just the commit SHA. So just to be aware of, it's mildly confusing. So even though it does say tree, that's not the case. All right, the statuses API is something that a number of people have touched on and is another one of those incredibly powerful things, especially if you haven't seen it before. So I thought of this phrase the other day, like how best to describe what the statuses API does. And I think this is the best one I've come up with. Who knows, maybe someone from the platform team is going to come up to me afterwards and say, that's a terrible idea, it's wrong, whatever. But stateful commits. So what do I mean by that? You want to be able to associate some data with a given commit. The most obvious example being something like CI status. So when you start to use our statuses API, say by using an integration like Travis, what will happen is we'll fire off a webhook, say when you push a new commit to GitHub, Travis will run the test that you told it to run, and it will report back the status of those tests, and it will associate a state with the commit. So in the screenshot example here, that's 2E46599. And in this case, we have 5 different states, actually. So 5 different CI tests, and in this case, all of them happen to be passing. So it's really, this is probably the canonical example by now for us of how to use our statuses API. That's what's happening when we offer an integration like with Circle or Travis or any of the other providers that you've seen in the integrations directory. Behind the scenes, they're just using our statuses API. So that means you could actually roll your own integration. If you have your own custom CI service or you just want to mess around, you can do exactly the same thing. And it's actually really easy just to write a few simple curl scripts if you just want to practice in some Scratch directory of yours. And the documentation for this is also quite good. So developer.github.com has our API documentation, and there's some really great examples that our docs team has put together there of just building your own CI server. So we're not going to actually, of course, take you through the entire thing. It's going to just be a rough outline. But if you want to learn how to use the statuses API, highly recommend that as a great place to start. So here's just another view of things. This would be the bottom of a pull request right here. In this case, again, 5 statuses. 3 of them are successful, and 2 of them are failed. And incidentally, these links back here, when you see details on the right-hand side, those are all the deep links, in this case, to the build output. So if I want to know why the PR build failed for Travis, I just go ahead and click details, and that's going to go take me over to the output on Travis of that particular build and test. And of course, if you're rolling your own, you could make that target URL whatever you want. So another useful thing is actually the deploy API, and you see that here with the ship it squirrels. So Cosima deployed to lab, that's the name we offer for one of our staging environments, and then later on, Croissant deployed to production right here. So much like the statuses API, the deploy API lets you represent certain events within the timeline view of a pull request. So you don't need to keep jumping around between all these different systems to understand, okay, what's in production, what's in arbitrary environment. It's a great way, again, to raise visibility of certain actions so anybody can see what the state of a given project is. Now, not only can you see via pull requests how many commits have been made, who's made them, what the latest versions are, you can also have those stateful commits, really. You can have CI statuses associated with them. And then you can take it another level. You can see, where is this code actually deployed? You know, is it still just living on GitHub, or have we actually deployed it to any environments? All right. A lot of people, they'll like to live on the command line and don't want to be in the web UI all the time. For you, I say check out Hub. Hub.github.com is a wrapper, really, for our API. And it lets you do a lot of GitHub stuff, not Git stuff, but GitHub stuff on the command line. Really handy. So you can do things like this, if the clicker works. All right, there we go. Hub checkout, followed by the URL of a pull request. So you don't have to go through all the individual Git operations. We'll just go ahead and take care of it for you. We will automatically create a new branch and check you out to it. So you can go right from a pull request view to the command line and check out the associated branch locally. So oftentimes, people are reviewing pull requests or trying to merge things on the command line, and you get into a really sticky situation. Say you're halfway through fixing a merge conflict, but you don't like where you've gotten, and you just need to get back to the original conflicted state. In that case, you can do something like this. This is a basic Git operation. Git checkout -- conflict, followed by merge or diff3. And what this is going to do is, say you have a conflict in Readme, and you've started to fix that, but you don't like where you've gone with it. If you run this command, you will actually get back the originally conflicted version of Readme. So you'll be back at that initial state of having the merge conflict. So it's a way to back out of changes that you, if you don't like the fix you've started to implement but not finished. The merge diff3 flags right there just have to do with what the actual conflict looks like in the file once it's restored. So merge is going to show you what is on your branch and then the branch you're trying to merge into. Diff3 will also include the version of the file as it existed at the common parent, so wherever both people branched off from. All right, another option you have if you're in the middle of a merge conflict and you're having a tricky time resolving it, you can do this. In a three-way merge, there are going to be 3 different versions of a given file that's conflicted, right? There's the version on the branch you're on, the version on the branch you're trying to merge in, and then the version from the common parent right there. If you want to actually check out into your working directory any one of those, you can with this syntax right here. So the n right there should be replaced by 1, 2, or 3. If you replaced n by the number 1, what you would do is go ahead and check out a copy of the file as it existed on the common parent commit. So the reason there's you give the n, so in this case number 1, followed by the path of the file you want to check out, and then the greater than symbol, and then whatever you want to call the file locally. So if the conflicted file is Readme and you want to check out the common parent version of Readme, you probably want to give it a new file name. Otherwise, it's going to overwrite the one that's in your working directory, namely that conflicted version. So 2 would be if you were to replace n with number 2 right there, what you would get is the version of the conflicted file as it exists on the branch you're on before that merge conflict. Number 3 would be from the branch you're trying to merge in. So it's a little bit esoteric. It's about as esoteric as I'm going to try to make anything in today's talk, but it's a really useful way to be able to get any of the 3 different versions of a file into your working directory when you're in the middle of a merge conflict. If you don't want to just look at a single file that has all those different merge conflict markers in it, you want to see what the files look like independently. So here's the next secret right here. So hat tip to Heather Baldry from GitHub. Secret in the sense that we talk a lot about GitHub being really useful for developers. We'd like to think it is, but it can be really handy for non-developers as well. So we've famously said before, GitHub uses GitHub to build GitHub. We also use GitHub to run GitHub. So it's not just developers or product managers or engineering managers and so forth that are using GitHub. We have things like the legal repo. So it's really handy, right? The legal team isn't opening too many pull requests, but you've got 7 right there, but we have at least 83 legal issues right now, evidently, or as of yesterday. So really handy. Issues are a great way to be able to communicate with people. We think much, much better than email. You have a single canonical place to go to. If anyone needs to get caught up on a conversation, you don't need to worry about being CC'd on a thread or having part of it or searching through email history. You get lots of rich contextual information. And in our case, it lets us stay in the same spot, so I don't need to be context switching between different apps all the time as well. So there's one of your final GitHub secrets is if you start to teach a non-developer how to use it, they will oftentimes grow to love it. It may take a little bit at first. That's fine. There can be a steep learning curve, but it can be incredibly useful even for non-developers. In fact, I've had a chance to talk to a number of you here who weren't necessarily writing source code on a day-to-day basis, but doing something like documentation. Our docs team uses GitHub heavily. All right, so there's always more out there, right? This is just a tiny, tiny sample of the Git and GitHub secrets out there. So one of the good resources is actually an open source repo. It's really a giant README and has an exhaustive list of a lot of the stuff that I've covered today and a whole lot more. Recommend you go there. Also, check out our blog. So Git 2.6 was released a few days ago, and M. Hager, who works for GitHub and is actually one of the core maintainers of Git, which I think is really cool. So M. Hager and another fellow named Pef, that's his GitHub handle, are actually two of the core Git maintainers, and they work for us. And I think that's awesome that we get to work with two people who are actively maintaining Git today. We like to post about new releases and point out the kind of things that we think would be interesting to different audiences. So you can just check this out. This was, there were a plethora of blog posts, as you might imagine, in the last several days. And this is probably number 7 or 8 going back. Also really cool, if you don't want to view the general blog, you want to just be able to get technical information, we relatively recently launched the GitHub engineering blog. So a lot of different posts by our whole engineering team. VMG, fellow back-end engineer who happens to do a lot of stuff with Git on our servers, has the latest post about how we count Git objects and how we did that a lot more efficiently. So there's really cool stuff in here that happens to come from our engineering team, telling you more, and you'll invariably discover some more Git and GitHub secrets in there. Another great one that I point people to a lot is how GitHub does branch deploys, which was one of the earlier posts on this blog by Aman. It's great if you want to read about how we at GitHub actually deploy our code out so that all of you can enjoy it, hopefully enjoy it, at least experience it. So I'm going to end it up right there. Thank you very much, everybody, and I'd like to stick around for as many questions as you have. Yep. Awesome. Mm-hmm. Yeah, the branch that's going to get merged in. Yeah, compare. So the question, thank you, Brent. So the question was, in the example of searching through pull requests, I showed that you could specify the base branch, meaning the branch that you want to merge into. Just type base, and the example was actually master. Can you do the same thing? Can you search by the branch that you want to merge in? The answer there is yes. It's just compare, followed by the branch name. It's a slightly less common use case because usually you're not trying to merge one branch into multiple locations, but it's absolutely possible. So, yeah. Yeah, right there in the 3rd row. So, yeah, exactly. So the question had to do with opening pull requests early, and more specifically, do we have any etiquette to make sure that people don't merge the pull request early? And the answer is yeah. So GitHub defaults to openness. You can, with things like protected branches now, prevent people from hitting the merge button. But we don't do that, generally speaking, and we do have an etiquette. So if it's a small ship, if it's a tiny change, you're adding one line or updating a typo, we say go ahead and merge it yourself. For pretty much everything else, we wait to get a sign-off, usually an emoji. So like a ship it squirrel, the actual ship, or a +1, something like that. And that's our internal convention. So yeah, it does require having a culture of trust, but that's something we try to build and maintain because we find that's a much more enjoyable and more effective workplace. So. Oh, so the question is about how one would use the compare view in general, and how one in day-to-day life might use the output of the compare view. Oh, on the dip. Oh, so it would be. So there's a close relationship between the compare view and the pull request. The compare view by itself is going to show you commits that are unique to a given branch right there. So that's going to be most useful if if a pull request has not been opened on that branch yet. That's the real use case for that. So somebody's pushed it up but doesn't happen to have opened a pull request yet. Generally speaking, if you have a lot of unique commits, and especially it's recent work, you intend to probably open a pull request. So that's why the button exists there, to go from the compare view to opening the PR, and then that's where the discussion would ensue, and presumably you want to ultimately merge it in. If you want to just have that discussion and you realize you don't want to merge it, you can always, of course, close the pull request and archive that discussion effectively, so it's still there, but you're never actually merging the branch in. So the question is, if you need a pull request to have a discussion, the answer to that is no. It depends on what kind of discussion you want. So you can have an issue, for example. Use GitHub issues to have a general discussion. Generally speaking, we will open an issue if we have a higher level discussion, but we don't know how that would actually look in source code yet. So like, do we want to redesign the home page? That's a discussion we'll have in an issue. Once we decide on a particular approach, then we say, okay, great, we'll open the associated pull request, probably use one of those fix, close, resolve keywords, and go from there. So yeah, so that's how we divide up the uses. Other questions? Anyone? In the back, yeah? I'm sorry, I'm having a little difficulty hearing you because the music has started out there. Oh, yeah. So the question had to do with an option that Hub gives you to turn an issue into a pull request. We don't happen to use it internally very much, so I don't have a very strong opinion on it. I don't happen to use it in my personal work, but that's not to say you shouldn't. I just happen not to have an opinion one way or the other. Yeah. Any other questions out there? Happy to entertain them. If it comes to you in 2 minutes after I've walked off this stage, feel free to just approach me directly. And if not, thank you, everybody. I hope you've enjoyed your time at Universe and enjoy the closing keynote.